All right, this is the January 2019 Algebra 2 exam. We're going to be starting with question number 1. So it says, suppose two sets of test scores have the same mean but different standard deviations, and these are the standard deviation symbols. So there's standard deviation 1 and standard deviation 2 for the two different sets of data. With the standard deviation for the second one being greater than the standard deviation of the first set of data. Which statement best describes the variability of these data sets? Variability is a big word to just represent the overall spread of your data. So if you think about just a quick review on standard deviations, here's my normal bell curve. Perfect. The mean is in the middle, and the standard deviation is how much I go out in each direction. So there's 1 standard deviations, 2 standard deviations, 3, and then of course the other way as well. 1 standard deviation, 2 standard deviations, and -3 standard deviations. Standard deviations also are a way of representing the spread because it's how far out your data would have to go. Let's say I have a minimum of like 10 and a maximum of 80. You would have to figure out what each one would have to go up by to be spread out that far. So standard deviation helps measure out the spread, and the variability of a data set is also representing the measurement of the spread. So the overall idea here is what I have boxed in blue, is that the standard deviation of the second set of scores is bigger than the standard deviation of the first set of scores. So if the standard deviation is bigger for the second group, that means it goes out by a bigger amount each time. Same thing in the other direction. That means the second group goes out in each direction a bigger amount because the standard deviation is bigger. If it goes out a larger amount than the first group, then data set 2 is going to have a greater variability. All right. And if it helps, just to throw some numbers out there, let's say the standard deviation of group 2 is 8, which is just bigger than 5, 2 random numbers. If I go out from some random number in the middle, let's say 10, I go out 8 and I go out 8 this way, I'm going to have this number and this number versus the second group, which has my fake standard deviation of 5. If I go out 5 and out 5, it won't go out as far and it won't be as spread out. So if that helps put it into perspective a little bit better as well. The standard deviation just represents that spread, and that's what variability is asking for. All right, number 2, not too bad. It's a transformation question. It says if f of x equals the log base 3 of x and g of x is the image of f of x after a translation, so that's just a slide or a shift, of 5 units to the left, which equation represents g of x? So if something is moving to the left, the two things you need to be thinking is that it's a horizontal change, which happens inside of the parentheses or inside of your function. And horizontal changes are also the opposite of what you would think. So for example, if this one is left, I would think left would be a minus, so this one's actually going to be a plus 5, and it's going to be in the inside of the parentheses. So I'm looking for a plus 5 on the inside. It's going to be this one. What's really nice about a question like this specifically, it doesn't work every time, but for this one specifically, it gives you an original function. That original function is log base 3 of x. You can then graph each one of these choices to see where it moved from that original graph. So if I go to my y equals, whoa, ooh, that was fun. I didn't know I could do that. I'm going to type in this with the base of 3, x, just put an x here, and then my next one, remember, that's the way you can type it in for the 84 calculator, Math Alpha Math. If you don't have the 84 calculator, here's how you would have to type it in. You would do log of x plus 5 divided by the log of the base. Both of these are correct, depending on your calculator, but they'll both, the second one and the y2 works for all the calculators. So that's the log change of base formula. When I plug these in, I know the choice 1 is my answer, but I can see my original graph was blue, and then the red one was the new one. It shifted to the left 5 units. If I graphed this one, it would have went up 5. This one would have went right 5. And if you graph this one again, just to make sure, it would have went down 5. So you would very clearly see that this one's your answer. You can't do that for all of the shift examples, but if you can, definitely take advantage of that situation and double check your answer. All right, number 3, when factoring to reveal the roots of the equation blah, which equations can be used? So it's saying when factoring So like in the process of doing the factoring, which equations can be used. So these are all essentially steps in factoring. So what I'm going to do is just factor this and then match up my steps once I have it factored. So when I look at this expression, or equation I should say, it has 4 terms, which means I am going to use grouping. So I'm going to group the first 2 together and group the second 2 together. And then when I do grouping, I have to do the GCF of each group. So the GCF of my first group is x squared. When I take out an x squared, I am left with x plus 2, which means that whatever I take out of my second group, I should also be left with an x plus 2. So the GCF of my second group to make that happen has to be a negative 9, because I need those negatives to cancel and I need those negatives to cancel to get me that x plus 2. So these match, which means we are doing it correctly. So I'm going to bring down that x plus 2, and then you put your 2 GCFs together, x squared minus 9. Now this can be factored again, but before I even continue on, I'm going to do what it's asking me to do and check the steps along the way. So this step right here is exactly this step right here, which is perfect. That means this one is correct, and it is an equation that can be used to help me get to my final answers. Oh, I didn't even notice this when I was doing it the first time. So let's continue on. Okay, so this next one, wow, I did not notice that. For the next one, you kind of notice that these 2 pieces are put together and the x and the plus 2 are split up. That's what happens when you have the 2 middle terms flopped around. It's still a correct way of writing this, because ultimately what I would have done from this step right here is then match up the 2, which is x squared minus 9, bring it down once, and then you put your 2 GCFs together, x plus 2. If I did that, I get the exact same step that I had up here, so that is also a correct statement. However, once you get to this, that's the only way that this part can be written, whether these were the GCFs or these were the GCFs. That part does not make a difference. Those are both correct. What you need to focus on is the signs. This is x squared minus 9, and this is an x plus 2. I can't have an x minus 2. That would not be correct. This is supposed to be a plus sign. So since that does not have the plus sign, that one is not correct, and that means that only 1 and 2 are correct possibilities for factoring this expression. And again, that's because if you look at both of these, if this was a step in my grouping, which it was the way that I did it, you bring this down and then you put your 2 GCFs together, and you'll get the same thing if you bring these down and put your 2 GCFs together. So 1 and 2 are both correct. All right, number 4, when a ball bounces, the heights of consecutive bounces, so like one bounce after the other, form a geometric sequence. Those are keywords right there. I'm going to box that in. It says the height of the first bounce is 121, so I'm going to start my sequence with that. And the height of the third bounce is 64 centimeters. To the nearest centimeter, what is the height of the 5th bounce? So we know that there's a 4th bounce, and then the 5th bounce is the one that I am trying to find. This is going to be my answer. So there's a couple things that I need to do, and I'm actually going to show you a couple ways to do this one, just because it could have been tackled a couple different ways. But the first thing I need to do is figure out what the ratio is. If I'm trying to come up with the 5th term of a geometric sequence, I'm going to use my geometric sequence formula, which is this. Given on the reference sheet, you just have to remember to go and look for it. And I'm going to plug my stuff in. Problem is, if I'm trying to find the 5th term, I would do A5 equals, my first term is 121. I would need to plug in R, and this would be 5 minus 1 up here because my N is 5. Unfortunately, I don't know what the ratio is. That's why it gave me the 3rd term. It's going to help me find the common ratio. So off to the side, I'm going to use that formula again. It's AN equals A1 times R to the N minus 1. However, even though I'm trying to find the 5th term, I can't use the 5th term over here because I don't know anything about the 5th term, and that won't help me. What I do know information about is the 3rd term. So I want to put the 3rd term right there, and the 3rd term is 64. But if this is the 3rd term right here, A sub 3, that means N is 3. So when I plug everything else in, I now only have one variable, which is right here, and I can solve this for R. So my first step to solve for R is to divide by the 121. And I'm just going to leave that as a fraction because it's not a great decimal. And 3 minus 1 is 2. And then to get rid of that squared, I'm going to square root this, and I get that r is 8 over 11. That means that's my common ratio. So to find my fifth term, I'm going to take that and put it where I needed it, which is right here, and then you plug that right into your calculator. So I end up getting that the fifth term is 33.8512396669 when I plug that right into the calculator, exactly as you see it. Don't forget that depending on your calculator, you might have to plug this in as one number, so just simplify it down to 4. We can do 5 minus 1 in our heads, no problem. So you end up getting 33.8, which rounds to 34 when you round to the nearest centimeter. Okay, that's the quote-unquote correct way to do it. Once you figure out what your common ratio is, what you can do instead... Again, this does not work every time, but since we're only finding the fifth term, it's not so bad. What I can do instead, let me just scoot this over. Once you find that common ratio, you can then use it to find the rest of the terms. So what I mean by that is the common ratio is 8 over 11. To get from one term to the next term in a geometric sequence, I would then have to multiply by 8 over 11. So if I do 121 times 8 divided by 11, I end up getting 88. That means that 88 times 8 over 11 should get me 64, and it does. So I multiplied that to get to this. So now I multiply 64 by 8 over 11, and I get a yucky decimal, but for now we'll just say it's 46.5 for repeating, and then times 8 divided by 11 gets you this exact answer that we had before that I erased because I needed more space. But you get the same answer, which ends up rounding to 34. So you get the same answer either way. Again, that only really worked because I was looking for the fifth term. If you were looking for like the 100th term, for example, this would not be the smartest choice. You would want to use the formula. So get yourself comfortable with the formula. It will benefit you more than this like guess and check sort of thing. But knowing sequences enough to know that you just keep multiplying over and over again is very helpful. All right, let's jump ahead to the next one now. And I'm going to need some space, so I'm just going to get rid of this. So number 5 says the solutions to the equation blah are. If I look at my answers, I'm seeing this plus or minus. I'm seeing a couple of my answers have an I. Ultimately, these answers, even though it doesn't tell me to use it, are coming from the quadratic formula. So remember what we talked about in class? You want to be focusing on the like the setup or the format of your answers, because they'll give you a huge hint about what you're supposed to do. Sometimes it'll be in quotient remainder form, which means long division. Sometimes you'll have answers that look like this, which come from the quadratic formula, and they're huge hints to help you out. Otherwise, I would have seen you guys maybe trying to start factor this, and like it's just not going to work out. These are not the kinds of answers that you get when you factor. Okay, now to use the quadratic formula, I need to be in this ax squared plus bx plus c format, and it has to be equal to 0, and it's not right now. So my first step is to subtract the 9 from both sides. And I end up with 5x squared minus 2x plus 4 equals 0. So that means a is 5, b is negative 2, and c is 4. So when I go to plug this into my quadratic formula, which is also on the reference sheet, by the way. Side note real quick too, on the reference sheet, it does not put these parentheses there. You only need these parentheses if b is a negative, but if you always put them in, it'll always be right. So just try to remember to add those green parentheses to the formula. They are not given like that on the reference sheet. Okay, so when I bring down the formula, it's x equals negative, and then b is a negative 2, so I bring down the negative 2. Bring down the plus or minus, bring down the square root, and then there's my parentheses again. I need them for this one because b is negative, so I put the negative 2 there, bring down the squared, minus 4 times a, which is 5, times c, which is 4, and that's all over 2 times a, which is 5. Okay, so my next step to tackle is underneath the square root. Notice I just got rid of that double negative and made it a positive. Underneath the square root, what you have to do is just plug in what's underneath. So when I say what's underneath, I literally mean just the underneath part. There we go. Which is negative 2 squared minus 4 times 5 times 4. And I get negative 76. So negative 76, and then that's over 10, because 2 times 5 is 10. So what I'm noticing right away is that I have a negative underneath my square root. That means I'm going to end up with an I in my answer. So this is not the answer, and this is not the answer because they don't have an I in it. So I got myself down to a 50-50 shot. Even if I was not great at simplifying, I can, at least get myself to that chance. But at this point, I noticed that the 76 is not the number that's underneath either of these square roots. So that's my indicator that I'm going to have to simplify the radical. Even though the directions don't say simplest radical form, again, you have to look at those answers to kind of see what the problem's asking you to do. So what you have to do is figure out the biggest perfect square that negative 76 can be divided by, and that's going to be 4. But since it's a negative, I want this to be a negative here. So it'll be a negative 4, and then underneath the other one's going to be the 19, because 4 times 19 will get me a 76. Remember, again, a hint that we talked about in class, you know that you have the biggest perfect square as long as another perfect square can't be taken out of 19. 19 can't be divided by any perfect squares, which means that 4 is the biggest, and you have found the biggest perfect square. Perfect. So I get x equals 2 plus or minus. My next step to finish simplifying the radical is to take the square root of negative 4, which is 2i, and then the radical 19 comes down, and that's over 10. Now, neither of those answers are over there. I'm seeing a bunch of 5s, which means I just need to simplify. So I need to simplify this and simplify this. So I get x equals 2 over 10 simplifies to 1 over 5. My plus or minus comes down. Here's another 2 over 10 that simplifies to 1 over 5 as well, with the I and the radical 19. So I wrote it a little bit differently, but you can see that if you multiply these together, it would be I with a radical 19 on top and then the 5 on the bottom, or you can write it as radical 19 over 5 with the I next to it, which is how they wrote it. But either way, the 19's under the radical. It is not a 66, so you get your final answer that way. All right, moving on to number 6. Julia deposits $2,000 into a savings account that earns 4% interest per year. The exponential function that models this savings account is blah, where t is the time in years. So t is years, that's my rate each year. Which equation correctly represents the amount of money in her savings account in terms of the monthly growth rate? So I have to take something that is increasing per year and change that up to be a now monthly growth rate. What you need to be asking yourself is if that percentage should be getting bigger or smaller. If I have this percent that happens over the course of the year and I'm going to split that percentage up into 12 months, it's going to be divided or getting smaller into those 12 months. So what you have to do is focus on the rate part of this equation, which is the 1.04. And to split that rate into a monthly rate, I'm going to raise it to the 1/12. So 1.04 to the 1/12, when you plug that in your calculator, gets you this number. Again, my decimal might be a little bit longer because I used my phone calculator, I believe. Sorry, just making some space. So this is the answer that I end up getting. I actually see that answer here and here. So this and this are gone. I'm going to be using that decimal. Now, here's the tricky-ish part. It's going to be raised to the 12t because if I take this number and I raise it to the 12th, it'll then put me back at this equation. And I'm trying to find an equivalent expression just that has the monthly rate instead. So it is going to be choice 3. Here's another probably easier way to tell that it's choice 3. If you guys remember, all exponential functions, which is what this problem is talking about, are in the format y equals a times b to the x. A is the starting amount, and b is known as your multiplier. Don't know if that's how you spell multiplier, but we'll just let that be because now I'm focusing on this. No matter what happens to your rate, this one went from a yearly rate to switching to a monthly rate, it doesn't really change your starting amount. The starting amount is still going to be depositing $2,000, so this amount is not going to change. So choices 1 and 4 were out right away. Your starting amount is not going to change. It's still an initial investment of $2,000. So it had to be this one or this one. The rate changed to this instead of that. So that's going to be your final answer, is choice 3. All right, number 7, kind of a weird question. It says, tides are a periodic rise and fall of ocean water. On a typical day at Seaport, to predict the time of the next high tide, the most important value to have would be the blah. So when we're talking about something changing periodically, this is like a sine, cosine, trig graph situation. When we were talking about high and low tide, it typically was a cosine curve because I'm at high tide right here. Then we hit low tide. Then we hit high tide. Then we hit low tide. Then we hit high tide. So that's 2 cosine curves right there. Not my best draft. But there's 2 sketches of cosine curves. It says, on a typical day, to predict the time of the next high tide, we have to look through these choices to figure out what the best representation would be. So really, I'm trying to go find the distance from here to here. This is what it's asking me to find. How could we find that? Let's read through the choices. Choice 1 says the time between consecutive low tides. So this is low tide and this is low tide. The time between them would be this. I will tell you right now that that is your answer because the distance from low tide to low tide is going to be the same as the distance from high tide to high tide because that is the period of the function. Period is the length of one curve. Even though this one's a -1, it's going to be the same distance as this one, which is a +1. So choice 1 is the answer, but let's look through the other ones just to verify. Choice 2 says time when the tide is 20 feet. If I find out what time it's at 20 feet, that's not going to tell me how long it would take to get from high tide to high tide. I would just know what time it was at the high tide of 20 feet. That's not going to help find the distance between high tides. Number 3, the average depth of the water over a 24-hour period. Not going to help me either. The average depth is talking about like this way, the depth of the water. That's not going to help me either because I was looking for the horizontal distance. And then the last one, the difference between the water heights at low and high tide, that would be taking this value and subtracting it from this value. Once again, measuring this, and that's not what I was looking for. I needed the length from high tide to high tide. So it's going to be choice 1. All right, number 8, and oof, yuck. Oh, this question is not so bad, but that equation was bad. So it says an estimate of the number of milligrams of a medication in the bloodstream T hours after 400 milligrams has been taken can be modeled by the function below. Over what time interval does the amount of medication in the bloodstream strictly increase? So when we're talking about these values right here, these are all time intervals, and time is represented by t. So it's asking you for the t values where the function, or in other words, the y values, are only increasing. The easiest way to do this example is to put it in your calculator and pull up your table. There's a couple ways you can tackle all these questions. Another way you could do it is plug in 0 for t into this, find out what that value is, plug in 2. It's a lot of plugging in. Your best bet is to plug it into your calculator and see how it's changing over the course of all of the times. So in my calculator, I go to my y equals, I'm going to clear it out, and then unfortunately I have to type in that awful, awful equation. So it's 0.5x to the 4th. Remember, you use x instead of t, plus 3.45x to the 3rd. Can't believe I'm even going to admit this, but I almost just said, please let me know if I type something in wrong. You probably won't let me know because you're on your own right now. Plus 347.7x. All right. Like I said, I'm looking at my table. Here's why that's going to be helpful. So you hit second graph, and this is the table that you get, and it says it's between 0 to 6. So really this is my t, not x, but it's going from 0 to 6. So I'm just going to put the numbers from 0 through 6, and I'm going to copy the table. So 0 has a y value of 0, 1 is at 255, this is at 344.4, 306.9, 193.2, 66, and 0. Great. Goodbye, calculator. So over what time interval, so over which of these values, does the amount of medication in the bloodstream strictly increase? So from 0 to 2, I'm starting at 0. It increases, it increases. It strictly increases from 0 to 2. That's going to be my answer, but you should verify the rest of them. So next, from 0 to 3, that means from here to here. It's going from here to up, and then down. It is not increasing from 0 to 3 because it ends up decreasing. 2 to 6 now. I look from here to here, decreases right away, gone. Nope. Strictly increase means it only goes up. So that's why using the table is actually better than plugging these values in. If you only plugged in 2 and only plugged in 6, you wouldn't get this middle story. You still would have found that it decreased because it went from 344 to 0, but sometimes you might need that whole story in the middle. So then from 3 to 6, same situation, it is decreasing. So that is not correct either. This one is out, and my final answer is 1. right, number 9. Ooh, this is a good question. Which representation of a quadratic, which is a parabola, has imaginary roots? Remember what imaginary roots look like, and this might not look like any of my graphs, but just a representation. Imaginary roots, by the way, are where it crosses the x-axis. So imaginary roots means you aren't going to see where it crosses the x-axis. So for example, maybe something like this. It could be something down here. It could be up here like this. It could be crossing the axis. Any of those have no roots because they never touch this x-axis here. So first one I see is the graph. It's probably the easiest one to eliminate right away because I see right here that it crosses at 3. Fun extra fact, it doesn't help with this question, but it is good to know. This is a double root because the vertex is the turning point. Okay, that is a double root, but either way, it is a real root because it crosses at 3, so that is not my answer. On a table, if you're not great with recognizing it on tables, you can actually plot these points. It wouldn't take you very long, and it would give you a better representation. But what you should hopefully recognize is this point right here, and this point right here. If I plot those points, negative 2, 0 is right there on the x-axis, and negative 0.50 is also on the x-axis. Anytime y is equal to 0, you will be on the x-axis because you're not going up or down at all. So this one has 2 real roots. That one's out. Okay, the next two, I want to see what the graphs of them look like. So what I'm going to do is go to my calculator, go to my y equals, clear this out, and type that in. So it's 2 times, oh my God, sorry. Oh, my dog just jumped off the couch and scared me so bad. So plugging this one in your calculator is a little bit trickier because of this number right here. I already plugged in this side, but I need to plug this in as well. I need it to be like a y equals, which means no other numbers can be over there. So I need to subtract that 64 over, so I get 2 times x plus 3 squared minus 64, and that's going to be equal to technically 0, but since I'm graphing it, I'm going to make it equal to y, so I need to type in that minus 64. So then I hit graph. Not the best graph. You could zoom in or out, but it's good enough for what we are looking for because I can see the full graph of it, and I notice that it crosses the x-axis. Doesn't even matter where. I just see that it crosses here and here-ish, so it crosses twice. So that means it has real roots. That can't be my answer. Oh, boy. All right, sorry. Good boy. All right, now for number 4, when I go to my y equals, I did it again. When I go to my y equals, what? What question are we on? 9? Okay, only a few more to go in this video. When I go to my y equals, it's probably going to be choice 4, but we're good students. We're going to check it anyway. This is 2x squared plus 32. This one's equal to 0, so I don't have to worry about moving anything over. It's already good to go. This is just like plugging into my y equals. I hit graph. I'm going to change my window so we can actually see it. Maybe. Hello. Oh my gosh. Sorry, this app is sometimes way different from the calculator. You don't have to actually clear it on your calculator, but I need to. I'm just going to go up to negative 20 and positive 20. Did I plug it in wrong? 2x squared plus 32. Nope, I need to go higher than that. My y max, I'm just going to make it 50. Okay, there it is. So, boom, boom. I can see right away that it doesn't cross the x-axis at all because these are never going to come back down. So this is completely untouched, which means that this is my answer for the one that has imaginary roots, which is what it was asking for. Something else that you guys can do, we didn't talk much about this in class, but if you can't really figure out your window and you can't find the graph anywhere, you could hit zoom and scroll down to zoom fit. It is not a great window, but it'll show you where your graph is. Like, see, it brought me all the way up to over 1,000. I didn't need that, but I can see that it doesn't cross the x-axis down here because the x-axis is at that number 0. So just another way of looking at it. Another way of looking at this, guys, I'm trying to give you as much info as I possibly can. If you solved this by factoring, you would have, oops. Actually, I'm not going to. Yeah, we'll do it by factoring. If I take out a GCF, that would leave me with a 2 out in front, and that'd be x squared plus 16. This can't be factored again because it is not the difference of perfect squares. So at this point, I would tee it up. Nothing happens over here, but then I have x squared plus 16 equals 0. And when I solve this by subtracting the 16 over, I end up having to take the square root of a negative, and the square root of a negative gets me plus or minus 4i. So there are two imaginary roots here, but you can see right away because I got that square root of a negative that would get you the imaginary roots. So there's a few different ways that you guys can solve literally all of these. Well, most of these, I should say. But it's good to know all of them because if you forget one way, there's always another way that you can try. Almost always another way that you can try. All right, next one, let's get this out of the way. A random sample of 100 people that would best estimate the proportion of all registered voters in a district who support improvements to a high school football field should be drawn from registered voters in the district. That was a very long sentence. So overall, when you're trying to find a random sample, the goal here is to find the option that would get you the least bias. Remember, bias is like unfair. The example we talked about in class is asking people leaving a Buffalo Bills game who their favorite NFL team is. Not exactly fair. So least bias means most fair. And in other words, most random. Okay, so we're trying to figure out who would support improvements to the high school football field. Can't really ask at a football game. That's not very fair. At a school fundraiser, that could be a fundraiser for a football team, but otherwise it's still people that are involving the school. So I'm going to say that one's slightly biased. A high school band concert, not so much, but the most random one here would be a supermarket. There are people there that aren't even affiliated with the school. They might not have any connection to the school, so that one would have the least bias. So this one's answer is going to be choice 2, which means the band concert is out. All right, 2 more for this video. Number 11, which expression is equivalent to blah? So this is another one of those hints for you guys. When it says equivalent to, it's not telling you what to do, but if you look at your answers, you can tell that it was clearly just taking this and simplifying to get to those. So we're just going to tackle this and start doing math and kind of hope that we get towards the answer. First thing I noticed is this squared. Squared means you have to write it out twice. So 2x minus I times 2x minus I. I'm going to bring down that minus sign and then bring down the rest. This is 2x minus I and 2x plus 3i. So what I have to do for this is multiply everything out and then do subtraction. You're still following PEMDAS no matter how difficult your math may look. I have to multiply before I subtract, so I'm going to double distribute over here and double distribute over here. And the minus sign for now is just going to come down, and these are going to stay in parentheses because I'm subtracting that whole thing. That'll come into play in a little bit. When I multiply out this first one, 2x times 2x is 4x squared. 2x times a negative I is a minus 2xi. Negative I times 2x is also a minus 2xi. Of course, I didn't give myself enough space. And a negative I times a negative I is a plus I squared. So I squared is something that we need to remember. You should have it memorized, but let's say it's your exam, you're panicking, you forget. Remember, you can plug it into your calculator as second decimal point, square it, and it gets you a -1. So we should have it memorized that it's a -1, but that's a nice backup for you if you forget. So that I squared is just a -1. Okay. Next part, when I go to multiply this out, 2x times 2x is 4x squared. 2x times 3i is a plus 6xi. In here, negative I times 2x is a minus 2xi. Boom, boom. And the last one, negative I times positive 3i is going to be minus 3i squared. So I'm going to do that same thing again. I squared is a -1, but this one has a -3 with it. So this whole term right here is -3 times -1. So I'm just going to replace that whole thing with a plus 3. Now I'm going to combine like terms. I have 4x squared. This will combine with this and get me a minus 4xi. And remember, that's just a -1. I'm going to kind of do this in one step right here. 6xi minus 2xi is a 4xi. And now I have to distribute this minus sign through. So that negative goes to this. That's going to be a minus 4x squared. When I distribute, remember this and this are replaced with that. So this negative is going to this, which is going to be a minus 4xi. And then when I distribute this to that last term, which is a positive 3, it'll become a -3. So my last step is combine like terms. My x squareds cancel. These do not cancel. I get a -8xi, and then a -1 and a -3 will get me a -4. And you'll notice that when you look at the answers, it's not written in that form because we want a plus bi. So the number comes first, then the I term. So this is going to be -4 minus 8xi, and that is choice 1. I feel like there's a lot of 1s on this exam. I'll have to go back and check that out. But that is my answer. All right, last one, let me just clear this up a little bit, is number 12. And we got 8%, so we gotta go. Suppose events A and B are independent and probability of A and B is 0.2, which statement could be true? So if it's independent and it's giving me information about the and, I want to use the and test for independence, which I totally have memorized like a good student. This is the probability of A and B equals the probability of A times the probability of B. Remember the test for independence, if they are identical or equal, it means they're independent. If it is different or not equal, that would be dependent. Sorry for my sloppiness, I'm just trying to go a little fast now. Independent is identical, dependent would be different. So because I know that this is independent, I know that they definitely have to be equal to each other. So I know that the probability of A and B is 0.2. The rest of this is giving me a bunch of other information, so I'm just going to test them all out. First, number 1. So using this rule, the probability of A and B to see if it's equal to the probability of A times the probability of B. I know they have to be equal. Let's test this out. The probability of A and B is 0.2, so I'm going to plug that in here. Choice 1 is saying the probability of A is 0.4, so I plug that in here, times the probability of B, which is 0.3, so I plug that in here. When I multiply 0.4 times 0.3, I get 0.12, which is not equal. If they're not equal, it's dependent, so this is not my answer. Remember, I'm looking for the one that's independent. So choice 1 is out. All right, now I'm looking at choice 2. So same thing, I'm going to be plugging it into this. Okay, I'm just going to leave it up there though. The probability of A and B is 0.2, and I need it to be equal to the probability of A, which for this one is 0.8, times the probability of B, which is 0.25. When I multiply 0.8 by 0.25, I get 0.2, which means these are equal and they are independent. That's my answer. But of course, I'm a good student. I'm going to keep checking the rest of my answers. Choice 3 gives me information about probability of A given B and the probability of B. So there's a couple things wrong with this. First, I have information about the A and B, which means I need probability of A, and I have to multiply it by the probability of B. This one didn't give me the probability of A at all, so that's not helpful. And another reason this one is not good is because if I use the given test for independence, that's this. This is the given test for independence. It doesn't give me any information about probability of A at all. So for this one, there's not enough info to even figure it out. That one's definitely out immediately. And then choice 4 gave me the probability of A and the probability of B. Man, people need to turn off their phones before they start recording videos. So I need to test this out again using my and test for independence. So once again, probability of A and B, seeing if that's equal to the probability of A times the probability of B. A and B was given in the directions, it's 0.2. And I have that the probability of A for choice 4 is 0.15 times the probability of B, which is 0.05. When I multiply those, I get 0.0075, which are different. So this one's also dependent and not my answer. The only one that got me independence was choice 2. All right, if you have any questions, please feel free to reach out, and good luck.